Hello everyone, today we will learn about resistors in the session. We will cover various topics related to resistors today, that what is a resistor, units and symbols of a resistor, how many types of resistors we have, how we can connect resistors in a circuit, resistor color coding and its power rating, and resistors applications in the circuits or in day-to-day life. Starting with what is a resistor. So resistor is basically a two-terminal electrical component. As you can see in the figure attached, that there are two terminals for your resistor. In case of battery also, we have two terminals, positive or negative, that is plus and minus. Similarly, in case of resistors too, we have two terminals which are terminal 1 and terminal 2. You can use either of the terminal as positive or negative depending upon your own choice. We have a relation by Ohm's law with the help of which we can calculate the resistance, which is V is equals to I into R, where V is the voltage that is supplied by the battery, I is the current that is flowing in your circuit, and R is the resistance, that is the particular value of resistor you have used. Now units and symbols. As you know that your weight is measured in kilograms, so kilograms is basically the unit of measuring the weight. Similarly, for resistors also we have a unit ohms. It is the standard unit, and we have various other units of resistors too, like milliohms, kilo ohms, and mega ohms. Just like you have various units of weight like milligrams, kilograms, grams, etc. Now you can see on the screen that there are two symbols drawn. First one is a fixed resistor and second one is a variable resistor. The difference between the two is, in case of variable resistor symbol, there is one arrow going downwards to upwards. Now we have types of resistors. Resistors are basically classified into two types, fixed resistor and variable resistor. We will learn about these two in detail one by one. Starting with the fixed resistor. So fixed resistors are those resistors whose resistance does not change with change in voltage or temperature. That means no matter in which temperature or what voltage you are applying in a circuit, the value for that resistor will remain fixed. That means it will not change. And fixed resistors are variable in shapes and sizes. That means in the market, fixed resistors are available in different colors, different shapes, and different sizes too. Examples of fixed resistors include carbon composite resistor, film resistor, wire wound resistor, resistance wire, etc. And this is actually the symbol which you can actually use in the electrical circuits. Second is your variable resistor. That is the another type of the resistors we have. A variable resistor is a resistor in which the electrical resistance value is adjustable. In, in case of your fixed resistors, you have two terminals only, but in case of variable resistor, you have three terminals. The third terminal is known as Viper. So basically, Viper here is a terminal which is used for adjusting the value of your resistance. A variable resistor is used because a potential divider with three terminals is known as potentiometer. That means you can call your variable resistor as a potentiometer too. Now we have different types of variable resistors like rheostat, potentiometer, thermistor, humistor, photoresistor, etc. These all variable resistors changes its value depending upon the temperature and the voltage or light that is falling on it. Next, we have different types of connections. That means we can connect our resistor in a circuit with two methods. First one is serial and second is parallel. We will learn about serial and parallel one by one. Series connection. A series circuit is a circuit in which resistors are arranged in a chain, so the current has only one path to take. That means, as you can see in the picture, that we have three resistors, resistor R1, R2 and R3, and we have connected these three resistors in a line, and a battery is connected to it that is represented with two lines with a V, that is the voltage. So in case of your series connection, when you connect your resistors in series, the current that flows through all the three resistors will be the same. That means if 10 amperes of current is flowing through resistor R1, then 10 amperes of current will flow through resistor R2 and R3 as well. So we have a formula for calculating resistance in a circuit, that is R is equals to R1 plus R2 plus R3, where you will keep all the values of your different resistors and then you will get your total resistance in a circuit. Suppose you have three 10 ohms resistor, then total resistance in a circuit will be 10 plus 10 plus 10, that is 30 ohms. Now the parallel connection. A parallel circuit is a circuit in which the resistors are arranged with their heads connected together and their tails connected together. That means terminal 1 of all the resistors are connected together and terminal 2 of all the resistors are connected together. But in case of your parallel connection, the current flowing through the three resistors will be different, but the voltage will remain same. That is the difference between parallel and series connection. Now we have a formula for calculating your resistance in a parallel, that is 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here also what you will do, you will keep the values of all the resistors in the formula and from there you will get the final value of the resistance in a particular circuit. Suppose you have three resistors of 30 ohms, then what you will do is you will write 1 upon R is equals to 1 upon 30 plus 1 upon 30 plus 1 upon 30, and doing the mathematical calculations you will get the total resistance in a circuit. Now we have different values of resistance available with us, so we can calculate the resistors value with the help of color coding. Now I will tell you that how we can calculate the value of a resistor with the help of the color codings. On the right side you can see a picture showing gray color resistor having four color bands on it, that is red, black and gold. So the two red colors at the start will tell you about the two, four, two digits of your resistance value, and the third one, that is your black, will be a multiplier. That means the value with which you need to multiply the first two digits, and fourth one is your tolerance. So on the left side you can see a table in which the color red is at number 2, that is red is having value 2 and the black is having multiplier value 100. So what you will do, you will write 2 2 first and then you will multiply it with 100 if you have a red color band at third number, and in our case we have black. So you will write 2 2 into 1 and then Gold. Gold is your tolerance, and tolerance is the small table, and gold is having the value plus minus 5%. So in case of this resistor having color bands red, red, black and gold, your value of resistance will be 22 into 1, that is 22 plus minus 5%. Here the important point is that tolerance is always calculated with a plus minus and in percentage always. That means your 22 ohms resistor can change its value plus minus 5%. That is, its resistance can increase plus 5% and decrease 5% depending upon the weather conditions and the voltage that is applying. So that is all about your resistor color coding. Next is resistor power rating. The power rating of a resistor is the specification given with the resistor that serves to tell the maximum amount of power that the resistor can withstand. That means it tells you about that how much maximum power if you give to your resistor, it will not be damaged. So for the power rating also we have a formula that is P is equals to V into I, and further you can derive more formulas from it using the Ohm's law formula that was V is equals to I into R. And the important point here is the more the power rating, the greater the physical size of the resistor will be. Suppose your power rating value is 10, then the resistor physical size will be less. And if the power rating is having the value 100, then the size of your resistor will be more. Now we have different applications for resistors. Applications means where we can use resistors. So resistors can be used for limiting the current that is flowing in the electric circuits. It can be used to lower voltage levels in the electric circuit. You can use resistors as a sensor also. For example, we have photoresistors that detects that how many light is present, thermistor that detects temperature in your surroundings, and etc. In electronic circuits, resistors are used as pull-up and pull-down elements to avoid floating signal levels. And we have many more applications of resistors too. Thank you. I hope you loved the session and the topic of resistors is cleared with you. Thank you so much.